Good morning, children. Today, in the class, I have explained the preparation techniques of haloalkane. The rest part we will be doing in this video tutorial. Okay, so that means we discussed that what are the major sources by which we can prepare haloalkane. Of this, the other reactions what we have seen here, this video will contain the first preparation of haloarenes starting from the alcohol. One more thing I am telling you that haloalkane, or that is commonly known as RX, is prepared through various sources. One of the most important source is alcohol. We use a number of reagents to have chlorination or bromination or iodination. The other sources are alkene, a double bond. We even have other reactions of other preparations of haloalkane through other various methods. So that all we will see togetherly. Now here, coming to the first preparation, that is from alcohol, the first important point comes to our mind that this preparation of alcohol to haloalkane is the commercial preparation or large scale manufacture for haloalkane. Now, as you all know, the large scale manufacture means we are getting this in ample quantity. That means the yield of the product is much more than the haloalkanes obtained from other resources. In this, we could use the chlorinating agents like phosphorus halides, then anhydrous zinc chloride with hydrochloric acid to form RCl. With the same with brominating agent, we are getting RBr, bromide, and with iodinating agent, we get RI. Let's see what are the various important facts regarding this. The first point, what I said, that haloalkanes are largely extensively prepared from alcohol. Why this happens? Why is alcohol taken as the most important or the chief source to prepare haloalkane? It is that alcohols are easily accessible. This term easily accessible is a key word given in your NCERT. So it means that alcohols are relatively less expensive and largely available. Now, the second very important thing is the chlorinating agent, that is the OH group, is to be changing to chloride group. we have various chlorinating agents like PCl5, PCl3, thionyl chloride SOCl2. We have hydrochloric acid with anhydrous zinc chloride. In this, the chief product is definitely RCl, along with we are getting H3PO3, phosphorus acid. When we take PCl5 as another reagent, the main product is definitely RCl. Along with this, we are getting POCl3 and HCl with thionyl chloride SOCl2. The products are RCl, the major product. Along with we are having SO2 and HCl. Now look at these three reactions. The major product is always the same, but the side products are different. Now these compounds are partly soluble in water. Here SO2 and dry HCl both are escapable gases. It means that when we are preparing alkyl chloride from alcohol using thionyl chloride, we are getting this as the major product, and the side products are automatically get removed from the reaction mixture because these are gases, so they will automatically get evaporated. Unlike that, this is liquid, so here we are getting a contamination of two liquids, mixture of two liquids, and then we have to separate. So it's evident that the yield of this product will be less. Here also this is in liquid state, so it's evident that we are getting the maximum pure product or good yield of RCl when we are using SOCl2 as the chlorinating agent. It means SOCl2 is the most preferred chlorinating agent among all others. Now let's come to the next one. We have another reagent I wrote, hydrogen chloride or HCl acid along with anhydrous zinc chloride. So this mixture of HCl and anhydrous zinc chloride, this is known as Lucas reagent. This reaction has a great impact in distinction of primary, secondary and tertiary alcohol. See how it is happening. I have taken a tertiary alcohol and this HCl in presence of zinc chloride anhydrous, what it will do, it will take up this H and OH. So automatically Cl comes over here. Now keep this point in your mind that along with this, the side product is water. As we all know, alcohols are soluble in water. same as hydrochloric acid. Means the reaction mixture is all in water medium or in aqueous solution. But the halide so obtained is only partly soluble. So it means what happens, in a container we have taken all colorless reactant mixtures, whether it is alcohol and HCl whatsoever along with this. We do find that since this is partly insoluble, we do find some milky or turbid solution, as the presence of halide group or the procedure of the reaction is justified. Now, you all know that in this reaction, we are actually breaking this bond as OH minus and this plus. Since it is a tertiary carbocation which is most stable, the turbidity or milkiness is shown instantly in the tertiary alcohol. And of course, if it would be a secondary alcohol, little less stable than secondary carbocation, so this turbidity or milkiness appears for secondary alcohol after certain period of time. And for primary alcohol, the reaction will never occur unless and until we will elevate the temperature. That means, in a nutshell, this Lucas test for primary, secondary and tertiary alcohol could be summarized as if it is a primary alcohol, it gives a turbidity, milkiness only on heating. If it is a secondary alcohol, it gives turbidity after certain time interval. And if it is a tertiary alcohol, it gives the instant turbidity or cloudiness. It means the reactivity of this alcohol towards Lucas reagent is tertiary most active, followed by secondary and then primary alcohol. This Lucas test again we will study when we will have this alcohol phenol chapter. The next very important thing over here is what we are getting. The next very important point is for bromination and iodination. We take a mixture of red phosphorus along with bromine or red phosphorus and iodine. But we do not take PBr3, PBr5 or PI5, PBI3, all these. Why? First thing is PBr3 or PI3. These are sterically unstable compounds. Think of this phosphorus, the small one, as the middle, while 3Br are extremely large. So it is obvious that the small phosphorus cannot hold all these three. The same thing is for iodine also. It is more large than the beer one. It means this PBr3 and PI3 are prepared during the course of reaction. That's why this is called in situ. During the course of reaction, we are able to prepare this PBr3 or PI3 from red phosphorus and bromine or red phosphorus and iodine to produce RBr or Ri. Now the question is, why do we take the red phosphorus when red phosphorus is of course much less reactive than white phosphorus, the other electron. The main basic reason for that is white phosphorus, though it is reactive, but it is highly poisonous. But red phosphorus become non-toxic, non-poisonous, not having any physiological ill effect. That is the reason why do we take red phosphorus and bromine or red phosphorus and iodine. Hope so this in situ and all these points are cleared. Now, the next very important point that comes over here is, this is a preparation, exclusively a technique for preparing haloalkanes. In case we are having the phenol with all such chlorinating agent, even with the best chlorinating agent, we can't expect that Cl would be formed. The reaction does not occur. Why? It is a substitution, and which kind of substitution? Here Cl minus is going to replace OH minus. Means the attacking reagent is a nucleophile, an electron-rich species. So this electron-rich species is always repelled by this pi electron cloud. Pi electron cloud, benzene is just a hexagon. A plain hexagon, above and below the pi electron clouds are there. So any nucleophile will experience a strong repulsion with this pi electron cloud. That's why the chlorobenzene cannot be prepared from phenol by using the normal chlorinating agent, even with the most preferred chlorinating agent. We also have some other preparations of bromo and iodo compounds by taking an azeotropic mixture. You know now what is azeotropic mixture, a constant boiling mixture. Azeotropic mixture of HBr to have the bromination, and with Ki or I2 in 95% phosphoric acid. This gives the alkyl iodide. Hope so. Till then, whatever is discussed, that is your alcohol to haloalkane preparation, is quite clear to you. In case still you are having any difficulty, please feel free to ask me. Thank you, children.